So guys, my name is Ramadhan Riyandi, and this occasion I will explain about the cross elasticity. So cross elasticity, I have to explain to you marginal elasticity of diamond. So if a goods A and a goods B having a grid of relationship, so we can create of the diamond function or diamond elasticity as the follow: quantitative diamond A and quantitative diamond B. Quantity diamond A is also function of the price A and B. This is same with the quantitative diamond B. This is also function of price B and B. And as you look at in here, quantitative diamond A is also having two variable independent, which one is price A and price B. This is same with the quantitative diamond B is also having two variable, which one is PA and PB. Now guys, if you want to looking for marginal demand, especially diamond A, you have to choose is A and C. In A, derivative quantitative diamond A divided by derivative of price A. In C, you can see in here, derivative quantitative diamond A divided by derivative price B. In A, we can see the explain about this. A is marginal, its demand is to relate to PA. But also in C, A is marginal, demand is to relate to PB and B. This is the P and product of B. Price B and product of B. And after we looking for marginal demand for A, quantity demand A, now let's move on to we looking for derivative quantitative demand B. Demand B is also B and D. In B, derivative quantity demand B divided by derivative price A. And D, this is the last for quantity demand B. This is derivative quantity demand B divided by derivative price B. And explain about this B and D, you can see in here. P's marginal demand is to relate to PA and A. In D, you can see in here, B's marginal demand is to relate to product and price B. Now let's move on to next agenda. So let's move to formula about this one. Guys, remember, this is we call it new. This is new, the formula of elasticity more than one product. So guys, as you can see in here, new demand A is price A divided by quantity demand A multiplied by derivative quantity A divided by derivative price A. And for looking for DB, new DB is for price B divided by quantity demand B multiplied by derivative quantity B divided by derivative price B. Now let's move on to the cross elasticity of demand. This is the topic I'm gonna be discuss with my friend for this today, cross elasticity of demand. So for elasticity for demand, calling new AB for price B divided by quantity demand A multiplied by derivative quantity demand A divided by derivative price A. This is for new AB. But for new BA is for price A divided by quantity demand B multiplied by derivative quantity demand B divided by derivative price A. So guys, this is for this version. If new AB, new BA smaller than 0 for PA and PB, this means if the elasticity AB and elasticity BA are less than 0 for certain PA and PB, this means that we have to enter one value, then goods A and goods B complement each other or are complementary. And guys, this means that a decrease in the price of one good will be followed by a increase in demand for both. This is for the smaller ones. This one. This is for the smaller one. And guys, for last ones, this is if new AB and new BA higher than 0 for BA and BB. This is where the statement is that decrease in the price of one good will be followed by increase in the demand for that good and decrease in demand for other goods. So we call it this is substitution. Now let's move to my friends.
Hello everyone, my name is Devina Nadifah and I want to explain about the marginal functions. First, the formula. This is the formula of marginal function. To find the marginal function, first we must find the derivative of qx divided to derivative of px and the derivative of qy is divided to derivative of py. After we find and calculate, if the value is negative, so the characteristic is complement. So they complement for each other. So if one goods have the price of one goods is decreased, the quantity demand of another goods will increase. But if the value is positive, the character will be competitive for each other. So if one good price is decreased, another goods quantity demand is decreased too. And the last, if these two derivative function is not equal, so the characteristic is they doesn't have any relations. So we already have the example, like the if depend function for two products is qx is equal to 17 minus 2px and minus py, and for the qy is equal to 14 minus px minus 2py. So the marginal function is, to answer this, we must find the derivative of qx and qy. First, maybe I will write the formula first. Derivative of qx divided to derivative of px. Derivative of qx divided to derivative of py. So is derivative of qy divided to derivative of px. Next is derivative of qy is divided to derivative of py. So first, we find the derivative of px based on the derivative of kx first. It's equal to, we just look to the kx, to the px, and then we just ignore the number. So this is minus 2 px. If we derive, it will be minus 2. And then the second, the derivative of py in the qx function is, we just look for the minus py only. We just look minus py is only will be minus 1. And then for the second function, we find the derivative of px first. We just see the px, and it will be minus 1 too. The last is to find the derivative of py. We just ignore the others, and it will be minus 2. So after that, we just look for the value, because the value, all of the value is less than 0 or be negative. Added to the derivative py as less than 0 or being negative, it will be, we can look at this negative, it will be have a complement characteristic. So they complement for each other. That's all for me.
Hello guys, come back with me, Farid Hidayat. So today I would like to explain you briefly about how to solve and how to found and how to answer whether the two products are complementary or substitution, like my friends mentioned before, with the question which taken from Kalangi's book. The questions as the follow. And we got the functions, quantity of product X and quantity of product Y, like this. And now how to find, and now what we are going to find is new of product X and Y and new of product Y and X, whether these products are complementary or substitution. Let's discuss together. The first thing that you have to do is find the derivative of each function. The first derivative is from quantity of X. The first is the derivative of quantity of X with the price of the derivative of price of X itself. So we just focus on the price X, so we ignore price Y. So we could just write down back here, and now we derive the price X. Now we got the first derivative, and the second is the derivative of quantity of price, the product of X with the derivative of price Y. So we focus on the price Y, so we ignore price X. So we just write down it back here, times. Now we derive. Or we could also write it like this. Sorry. Now we got the second derivative. Now we move on to the derivative of quantity of product Y. We call it the derivative S. Derivative of quantity of product Y with the derivative of price of Y itself. X first. And then we derive this function, the quantity of Y functions. Now we got the third derivative, and the last is the derivative of quantity Y divided with the derivative of function, the price of Y. So we just focus on the Y, so we put back the price X. Or we can also write it like this. Now we got all the derivative from quantity of product X and quantity of product Y. Now we want to find out the new of product X and Y, and nu of product Y and X. Before that, we can also know whether each products are inelastic, elastic, or unitar with differential approaches. So we got the formulation like this for X and for Y products. And what we are need to do is just substitute what we got, the derivative for each products into this formulation. Times px, because we don't have px value yet, so we just write it down back. Then qx and now we can eliminate the sum amount like this. Py power of minus 0.4, we could eliminate it with the same amounts. And this px power of minus 2.5, we can also do this like this, right? We can change the px above into below, and also don't forget to add 1. Now after this, we can eliminate the same amount. So x, the elasticity x is minus 1.5, and also we gonna find out the product y, and also we substitute the derivative that we got here. Times py, because we don't have the amount of py yet, the value of py yet, so we just write it on back here, and also divided by quantity of y. We just put the function of quantity y. Now we can also eliminate the same amounts like this, the same, and also we can do this like this, right? We can put py above into below, and we got py power of minus 1.4, and also we can eliminate it. So y is and how to determine it is unitar, inelastic, or elastic is that the absolute amount, whether the absolute amount is below or above or equals 1. So this amount is above 1, so it is elastic. That we already discussed in previous chapter, that amount that above 1 is elastic. And for y, because in absolute form 0.4 it's below 1, so it is inelastic. So x is elastic and product y is inelastic. If we want to find out the mu of x and y and mu of y and x, whether these products are complementary or substitution. So to find out is the formula, because we want to know the elasticity of product y, x and y. So we take a look at back the derivative that we already discussed and that already solved. So we take it from the derivative that has a combinations with the product y and product x. So from this derivative, we find out that number 2 and number 3 has the combinations between product x and product y. So for finding out this new elasticity, the formula as follows. Derivative of quantity of x with the derivative of price of y times price of y divided by quantity of x. So what we are gonna do is we just need to substitute what we already got in here into the formulation. So we already got the derivative of quantity x with price y right here. So we put it back here. Times py, because we don't have amount of py yet, so we just write it on back, divided by quantity of x here. Now this is the commons or the basic mathematics, so we could just eliminate the same amount. So from this function, we found out that sum of function has the same amount, like the price of x, the price of x, the power of minus 1.5, and we eliminated with the same amount. And then for this, we could also do this. Right? So we could also eliminate this with this. So the end result is the minus 0.4. So for new x and y is minus 0.4. So we also find that new of product y and x. The same. The formulation is almost the same. Quantity of y with the derivative of price x times price x divided by quantity of y. So we just substitute all what we got here into here. So the derivative of quantity y with the price of x. So we took back here. Just write it down back here. Times py times px, because we don't have the amounts of the value of px itself yet, so we just write it down back, divided by quantity y, the function of quantity y. Px 5 py 0.4. Now we like what we just did before, we just eliminate the same amount. So we find out that py is the same, and also this we could also do this. We can put the px or py here to the above right and to the below right, and it becomes this. So after that, we could also eliminate the px because it is the same amount. So the last result is minus 0.5. And after that, after finding out that the result of the new product x and y is minus 0.4 and new of product y and x is minus 0.5, so we could conclude this amount of this value are below 0. So it means these products are complementary. Why? Because the amount of this product x and y are below 0. That's all for me.
Hi, I'm Amir. Now we are going to learn how to find the extreme value between two different products and prices with differential approaches. Now, let's say TC equal QA to the power of 2 plus 3 QB to the power of 2 plus QA times QB. And price A equals 7 and price B equals 20. Now we need to find the revenue of A by QA times QA, and the result is 7 QA. And then we need to find the revenue of B by QB times PB equals 20 QB. And then after we find the revenue of A and revenue of B, we need to find P by total revenue minus total cost. So total revenue, we move these things into this and then minus and remove the total cost. We move these things to this and this is the result. The result is 7 QA plus 20 QB minus QA to the power of 2 minus 3 QB to the power of 2 minus 3 QA times QB. Why this is minus? This is minus times plus equals with minus. So after we find the result, we need to find the value of QA and the value of QB with derivative function. So derivative P divided by derivative QA equal with 7 minus 2 QA minus QB. So how we found this result? So we need to find number with QA on it, like 7 QA. The derivative of it is 7. How about 20 QB? Because it's not QA on it, we just forget about it. And then minus QA to the power of 2. The derivative of it is minus 2 QA. And minus 3 QB to the power of 2, because it's not contain QA on it, we just leave it. And then minus QA times QB. The derivative of it is QB. So do with derivative P divided by derivative QB. And this is the result. The result is 20 minus 6 QB minus QA. And then we need to do what we call elimination and substitution. Firstly, we need to do elimination first. I think you guys already know how to do elimination, and the result and we found that QB is 3, and then we need to do some substitution. We use this minus 2QA formula, minus QB equal minus 7. We replace QB with 3 and to find the QA. And after we calculate, we found that QA is equal with 2. So now we already know the QA value is 2 and the QB value is 3. Now we need to do the P formula again. So this is the formula that we have taught before. We need to replace QA with 2 and QB with 3. And the result of this formula is 37. So the P value is 37. Now we need to find, is it maximum or minimum? Now, how to find is it minimum or maximum? So to find maximum or minimum, we need to do second derivative again. This is the formula. Second derivative P divided by second derivative QA equal with minus 2. And second derivative of P divided by second derivative QB equal with minus 6. So both of them, it's minus. It's under 0. It means it's maximum. So this 37, this P value, which is 37, is a maximum value of all of this thing. Now, if you want to learn more about it, my friend will explain you more detail.
And now I will explain you another example for minimum and maximum value. This is the question and I will explain to you step by step. For the A question, the first thing first, we have to find what is the value of revenue for product A and product B. And the formula of the revenue is quantity times price. We just have the price right here, so we just write the quantity and the price is 9, so we have 9 QA. This is the revenue for product A. And for the B, we do the same, QB times the price of product B is 12, so we have 12 QB. And the second step, we have to add them up for the total revenue. So we just revenue A plus revenue B, it's 9 QA plus 12 QB. And the third step, we have to find the function of fee. Fee is profit for this question, and the formula of fee is total revenue minus total cost. We have this total revenue function, so we just write it down, 9 QA plus 12 QB, and minus, we brackets them, and the function of total cost is this from this question. We brackets them up to QA power of 2 plus 5 QB power of 2 plus QA times QB. Because this function is there is brackets, so we multiply the minus into each number for this function. So we write this down again, 12 QB minus 2 QA power of 2, and this is minus 5 QB to power of 2, and this is minus QA times QB. So this is the function of fee for the profit. And the next step, we derive the function. The first function is from this function, okay? We look for the function, the derivative of quantity A. So we just look for the numbers that contain quantity A. So it's just this, and this. The derivative of 9QA is 9 minus 4QA, because this is the derivative for this number, and the derivative of this number is just QB, and we do the same for derivative for QB function from this P function, and just this, and also this. So we got 12 minus 10 QB minus QA. After this, we eliminate this function. So we grouping it if the number contains QA, so we arrange it with the same variable. So QA with QA and QB with QB. This is we move to the left side, and because this is the plus, because we move it to the left side, we add the minus. Okay. Because we have to find the value of QA and QB, so we have to make one of them equal to 0 when we deduct it. So I will choose this one. I will choose this QB for the 0, and I will search for this QA, value of the QA, I mean. And I will multiply this with 10, minus 10, and I will multiply this function with minus 1. So, okay, this is the new function. I'm sorry. This is 40 QA minus 10 QB equal. I'm sorry. This is have to be plus, because minus times minus is equal with plus, and minus 9 times minus 10 is plus 90, and this will be plus QA plus 10 QB equal to 12. And we deduct it, so this QB is equal with 0, and I can find the QA value. 40 QA minus QA is 39 QA equal to 90 minus 12 is equal with 78, and we divided 78 divided to 39 is equal with 2. So the value of quantity product A is equal with 2. And the last step for the A question is we have to substitute this QA into one of this function, and I will choose this function. So QA plus 10 QB equal with 12. We already know the value of QA, so 2 plus 10 QB equal to 12. This is 10 QB because we move it to another side, so this is will deduct by these 2, and the value will be 10, and we divide the 10 with the 10, and the last value of QB is equal with 1. So this will be the maximum value for quantity A, and this will be the maximum value of quantity B. And for the B question. Okay, now we move to the B question. B question is about Pmax or profit maximum, and we have this function from TR minus TC function. And because we already know about the value of QA and QB, I will write it immediately. The QA is equal with 2, and the QB is equal with 1. Okay, and 2 power of 2 minus 5 times 1 power of 2 minus, okay, I'm sorry, minus 2 times 1. This is 18. 12 times 1 is 12. And this is 2 power of 2 is 4. 4 times minus 2 is minus 8. And this will be minus 5. And this will be minus 2. Okay, so we calculate it, and it will be equal with 15. So the profit maximum for this function and this price of product is equal with 15. Now we will find the second derivative to define is this the minimum or maximum value. second derivative of this function to key A is equal with 4. Okay, just like there. And the second derivative from phi function for the QB is equal with -10. And because the two products, the A and B is the minimum, has a minimum value or less than 0, so it means that this function is maximum value, has maximum value. Okay?
Thank you.
Thank you.
See you.